All right, hello there. This is video number 24. And this is the beginning of chapter 11. So chapter 11, section 1. And this chapter is all about series and sequences, which we're going to talk about what those are, and some probability. So a series and a sequence is a number pattern. So here's a definition for you. A sequence. Oh, let's do this first. This is sequences and their notations. Okay, that's the name of this guy. All right, so a sequence is a function whose domain, remember the domain are the x values, is a set of positive integers. All right, instead of using function notation, sequences are usually written using subscript notation. You've seen that before in the slope formula, y sub 1 or y sub 2 minus y sub 1 over x sub 2 minus x sub 1, as shown below. And so, oh, whoa, why did that pop way down there? Holy cow. Let's put him back. As shown below. Okay, so if we have something like a sub 1, a sub 2, a sub 3, a sub 4, ... and those continue. So these things are terms in the sequence, and the domain, these are your domain. Notice they start with, sometimes you'll see an a sub 0, but not generally. So they start with 1 and they go up, and these terms continue all the way up until a sub n, and this is what we call the nth term. And that's important. You're going to be learning about the nth term and how that's going to be useful to you. All right. So here's a statement here. If the domain consists of the first n integers only, then the sequence is a finite sequence. Meaning it has an end. An infinite sequence does not. So otherwise, it is infinite. Okay, and you'll be able to tell the difference when you get involved in these a little bit more deeply. Okay, so here's an example. Let me scroll down the page a little bit. Given a sub 1 is 1, and a sub 2 is 2, and a sub n equals a sub n minus 1 plus a sub n minus 2, find a sub 3, a sub 4, and a sub 5. Okay, so that's what a problem would look like. Now, let's see how we're going to actually work this thing out. I'm going to extend my page just a little bit. All right, there we go. So we need to find a sub 3, a sub 4, and a sub 5. And we have this formula given to us, which is, now, a sub n, notice the n is equal to the subscript, right? So n is the subscript. So when we're looking for a sub 3, n is 3. When we're looking for a sub 4, n is 4. And when we're looking for a sub 5, n is 5. Okay, so that's important when you fill in these formulas right here. So we're going to go a sub n minus 1, which means a sub 3 minus 1 plus a sub 3 minus 2. And then if we figure out what that is, well, 3 minus 1 is 2, so a sub 2. And this guy, 3 minus 2 is 1, plus a sub 1. And we were given these values in the original problem. A sub 2 is 1, and a sub 1 is also 1, so we can substitute here. 1 plus 1 is equal to 2. Therefore, I'll make a list over here. A sub 3 equals 2. And eventually we'll have a sub 4, and we'll have a sub 5. And then I'm going to have you predict, or we'll solve if you can't, a sub 6, a sub 7, and a sub 8. Okay, let's see if we can figure out what those are going to be. All right, so let's go back and do a sub 4. Well, remember our formula is a n minus 1. 4 minus 1 plus a n minus 2 is 4 minus 2. And you could fill these in right off the bat and then go back and do the math, right? We could go a 5 minus 1 plus a sub 5 minus 2. Okay, so now we have, going back up to this guy right here, we have 4 minus 1 is 3, and 4 minus 2 is 2. So we have a sub 3 plus a sub 2. We know a sub 3, we just found that. A sub 3 is 2. And we know a sub 2 that was given in the problem is 1, and this equals 3. So this guy is equal to 3. And then let's go down here. So 5 minus 1 is a sub 4. 5 minus 2 is a sub 3. Well, a sub 4 we just found is 3. And a sub 3 we found earlier is 2. And so this is 5. And so this is 5. All right, so we know a sub 1 was 1, and a sub 2 is also 1. So take a look at what we've got here. This is a pretty famous sequence, actually. A sub 1 is 1, and a sub 2 is 1. Then we have 2, then 3, then 5. Let's do a sub 6 as well. A sub 6 is going to be a sub 6 minus 1 plus a sub 6 minus 2 is going to be a sub 5 plus a sub 4. So what's actually happening here? I'm taking the two terms previous to the term I have. The two terms previous to the terms I have right now. Right? So the two terms previous are 3 and 5. And I'm going to get 8. So I'm taking the two terms previous and I'm adding them, and I'm getting the next answer. Well, that gives me a prediction here for a sub 7. I'm going to get 13. And then if I take those two and add, I'm going to get 21. And maybe some of you are aware, maybe some of you are not, maybe some of you pay attention to the clothes I wear, I don't know. But this is called the Fibonacci sequence. And I have a shirt that says 1, 1, 2, 3, and then it says Fibonacci on it. It says something about counting and Fibonacci, and I don't, maybe people don't get it, but that's actually what's happening. So the Fibonacci sequence is super famous because it's actually found a lot in nature. It's found in weird places. It's found in the design of pine cones and snowflakes and seashells, and I feel like I want to say cauliflower. It's found in all sorts, sunflowers. It's found in all sorts, a lot of flowers actually. It's found all over the place. You should look it up on the internet. It's kind of cool. It also generates something called the golden ratio. Oh, that's not ratio. That's ratio. Something else that is very interesting and unique and goes back, oh my goodness, I don't know, to like ancient Egypt or something. Sorry, I'm drinking coffee while I'm making this video. So anyway, all right, that's the end of this page. This is 11.1 in your notes. Let's flip the page. So anyway, well, let's just review 1 second here. All right, all 1, 1, 2, 3, 5, 8, 13, 21. Those numbers create a sequence. This pattern up here, this is called the nth term. This pattern here that you can plug in 1, then 2, then 3, then 4, then 5, successive numbers for n, and generate these terms. And we're going to be talking about more and more of these. And this starts out pretty basic. It's going to ask you to, it's going to give you some nth terms and say, find the first number of terms. Then it's going to turn it around on you and it's going to give you these. And your job is going to be to find the nth term. And for me, those are kind of challenging, but some of you are going to be better at it than others. So we'll see how it goes. All right, I'm going to flip the page here in my notes. Okay, so here is your first problem here. Oh, let me grab, I'm going to try to use this paper, see if this doesn't help me be a little bit more neat. Write the first 5 terms of the sequence. With the following general term. So I took these problems directly out of varsity. So they're calling the general term the nth term. Okay, just so you are familiar with different terminology. Starting with a sub 1. And the a sub n is 6n plus 5. And so the best way to do this is just to make a list. So we have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Make an equal sign for each one of those. And then all we're doing is you're going to let n equal the subscript. So here we're going to go 6 times 1 plus 5. And I'm just going to do the substitution. Then we'll do the solving. 6 times 2 plus 5. 6 times 3 plus 5. 6 times 4 plus 5. 6 times 5 plus 5. Okay. And then get rid of this box over here. So these now equal 6 plus 5 is 11. 12 plus 5 is 17. 18 plus 5 is 23. 24 plus 5 is 29. And 30 plus 5 is 35. Okay, so I don't remember exactly how this looked in varsity. I think it actually literally gave you 5 boxes like that with commas, and you just filled in 11, 17, 23, 29, 35. I'm pretty sure that's how that looked. Okay. That's how I would organize it on my paper, though. I mean, you can clearly do whatever you like there. Okay, next. Oops, pen. Let's do this guy next. Write the first 5 terms. For a sub n is equal to n minus 2 over n plus 6. So these can be fractions. They can have exponents. They can have negative exponents. They'll have all sorts of things. So I'm going to do a few examples here to get you started so you can see the different types of things that they can look like. And then we'll go from there. All right, so again, I'm going to list off a sub 1. I think I'm going to skip a line for each of these. A sub 3, a sub 4, a sub 5, just because I have fractions. And remember, n is the subscript, so this is going to be 1 minus 2 over 1 plus 6, 2 minus 2 over 2 plus 6, 3 minus 2 over 3 plus 6, 4 minus 2 over 4 plus 6, and 5 minus 2 over 5 plus 6. Now, when you simplify these, make sure that you are reducing and putting things in simplest terms. Okay, some of these you're going to get some crazy, weird, insane numbers for. So this is going to be a negative 1/7, not reducible. This is going to give you 0 over 8. Make sure you reduce to 0. This is going to be 1/9. And then we're going to have 2 over 10. Make sure that becomes 1/5. And then 3 over 11. Okay? All right. Next one. Write the first 5 terms. For, that's an O, a sub n equals n squared times 3 to the minus n. Now, if I was you, I would take this. I don't like negative exponents ever. So if you don't remember the rule for negative exponents after doing all those logs, shame on you. I would take that and write this as a to the n equals n squared times 1 over 3 to the n, which you can then write as n squared over 3 to the n. And I would make this my nth term going forward. Okay, so now, using that, I'm going to go a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So these take up a bit of space. I mean, I like to space things out on my paper, but remember, we're doing the subscript is your n. So 1 over 3 to the 1. This is 1 squared, right? 2 squared over 3 to the 2. 3 squared over 3 to the 3. 4 squared over 3 to the 4. And 5 squared over 3 to the 5. So I have these in my notes where I can just kind of copy them real quick, but you may need a calculator if you don't know things like 3 to the 5th. I didn't. I know 3 to the 4th off the top of my head, and then simplify all these. Don't ever leave these powers on these things. So this is 1/3. 2 squared is 4. 3 squared is 9. 3 squared is 9. 3 cubed is 27. 4 squared is 16. 3 to the 4th is 81. 5 squared is 25. 3 to the 5th is 343. And so that's the first 5 terms of that guy. All right, and then one example at the bottom. So this is going backwards. So now you're going backwards. says determine the general term. What I always knew as the nth term. Varsity uses that general term for the sequence 3, 12, 27, 48, and notice it goes on and on and on. So your job is to find a sub n equals something that's going to generate all of those terms when n is 1. So when n equals 1, we need to get 3. When n equals 2, we need to get 12. When n equals 3, we need to get 27. And when n equals 4, we need to get 48. And this pattern needs to hold all of the time. Okay, so sometimes it's multiplication. Sometimes it's powers. There's all sorts of things that you need to try to look for. So you're looking for patterns. Especially patterns. Especially multiplication. Like you're looking for multiples of a number. Or powers. Like 2 to the first, 2 to the second, 2 to the third, that kind of thing, or something like that. And so what I notice in here is that going back to these values, 3, 12, 27, and 48 are all multiples of 3 somehow. So this is 3, this is 3 times 4, this is 3 times 9, and this is 3 times 16. So I guess this is 3 times 1. That's one way to look at it. So if I can pull a 3 out of all of these, this is a number that would come first in my nth term, and I can write 3 times something. Then I have to figure out how can I write these numbers in terms of n. And there's no formula for this. And it's just you knowing numbers and being able to find a formula. So for me, what I noticed is this is 1 squared, this is 2 squared, 3 squared, 4 squared, which means if n is 1, n is 2, n is 3, n is 4. So this is n squared. And so if I go 3 times n squared, that would be my nth term, and that worked out for that. So these are trial and error. Me doing 16 of them isn't going to help you. It's just kind of guess and check. There's going to be more of these in the upcoming examples. Have fun. All right, that's 11.1. There's going to be varsity day tomorrow, and then notes on the next one after that. All right, toodaloo.